Hi, I am Anuksharata and today I am here to present my second task presentation whose topic is Fastag fraud prediction. The problem statement is as follows. This internship project focuses on leveraging machine learning classification techniques to develop an effective fraud detection system for Fastag transactions. The dataset comprises key features such as transaction details, vehicle information, geographic location, and transaction amounts. The goal is to create a robust model that can accurately identify instances of fraudulent activity, ensuring the integrity and security of Fastag transactions. The dataset description is as follows. We have the following columns: transaction ID, unique identifier for each transaction, timestamp, date and time of the transaction, vehicle type of vehicle involved in the transaction, Fastag ID, unique identifier for Fastag, toll booth ID, identifier for the toll booth, lane type of lane used for the transaction, vehicle dimensions of the vehicle, transaction amount associated with the transaction, amount paid for the transaction, geographical location details of the transaction, vehicle speed of the vehicle during the transaction, vehicle plate number, license plate number of the vehicle, and finally the fraud indicator, that is our target variable, binary indicator of fraudulent activity. The project objectives are as follows. First is data exploration. In this, I was required to explore the dataset to understand the distribution of features and prevalence of fraud indicators. The main goals of data exploration are to identify potential relationships between variables, detect outliers or anomalies, understand the distribution of the data, and gain insights that can guide further analysis or modeling tasks. The code for this is as follows. First, we load the dataset. The code imports a library called pandas, which helps in working with data. It loads a dataset from CSV file. Then we display the first few rows of the dataset. This line prints out the first few rows of the dataset, providing an initial glimpse of the data and its structure. Then I check for the dimensions of the dataset, giving an idea of the dataset's overall shape. Then is the summary statistics of numerical columns. I print out summary statistics for numerical columns in the dataset such as mean, median, minimum, and maximum values, providing insights into the distribution and range of numerical data. Then I check for missing values and I print out the total count of missing values for each column, helping identify potential data quality issues. Then I print out the data types of all the columns so that we can distinguish between numerical and categorical data types. Then I print out unique values in categorical columns. In each categorical column, I give an overview of the different categories or classes in the data. Then I visualize the distribution of numerical columns. I display the pairwise relationship between numerical variables, such as in the form of scatter plots and histograms along the diagonal. The visualization helps in understanding the relationships and distributions of numerical features in the dataset. The second task objective of this project is feature engineering. In this, I am supposed to identify and engineer relevant features that contribute to fraud detection accuracy. Feature engineering is the process of creating new features or modifying existing ones in the dataset to improve the performance of machine learning models. It involves selecting, transforming, and creating features that are relevant and informative for the task at hand. The code for the same is as follows. Feature extraction. First, we import necessary libraries. We start by importing the required tools to work with data. Second, we load the dataset. We bring in the Fastag fraud detection data we want to work with. Then, we do the feature engineering. Now we enhance our data to make it more useful for our analysis. We convert timestamp to date and time. We convert date and time data into a format our computer can understand. This allows us to work with the date and time information more easily. Then we extract data and time features. We separate the date and time information into individual parts such as the day, month, year, hour, and minute. This helps us analyze patterns in the data based on these time-related factors. Encode categorical values. We change certain types of data like vehicles or locations into numbers. This makes it easier for the computer to work with this information and find patterns. Then we extract features from vehicle plate number. We look for specific details in the vehicle's license plate number like the state code or vehicle category, which could be helpful for our analysis. Then we drop unnecessary columns. We remove columns from the dataset that we don't need for our analysis. This helps keep our data organized and focused on what's important. Then we save the engineered data set into a new file. We save our modified dataset and use it for further analysis later on. The third task objective is model development. In this, I had to build a machine learning classification model to predict and detect Fastag transaction fraud and evaluate and fine-tune model performance using appropriate metrics. Model development is the process of creating, training, and evaluating machine learning models to solve a specific problem or task. It involves selecting the appropriate algorithm, pre-processing the data, tuning model parameters, and assessing the model's performance using various evaluation metrics. The code for the same is as follows. Next is model development. We first load the dataset by bringing in the data that we want to work with. Then we prepare the data. We split the dataset into two parts, features and the target variable. The features are the characteristics of each transaction that we will use to predict fraud, while the target variable is whether the transaction is actually fraudulent or not. Then we split the data. We divide it into two sets, one for training our model and the other for testing its performance. This helps us ensure that our model can accurately detect fraud in new transactions it hasn't seen before. Then we choose a model, and I have chosen a random forest classifier. This model is good at finding patterns in data and can help us identify fraudulent transactions based on the features that we've selected. Then comes the training of the model. We teach the model how to recognize fraudulent transactions by showing it examples from our training data. The model learns to associate certain features with fraudulent activity during this training process. Then comes the prediction making. Once the model has been trained, we use it to predict whether new transactions in our testing data are fraudulent or not. The model looks at the features of each transaction and decides whether it's likely to be fraudulent based on what it learned during training. Then comes evaluating the performance. We assess how well our model is doing by comparing its predictions to the actual outcomes in our testing data. We look at metrics like accuracy, confusion matrix, and classification report to see how often the model correctly identifies fraud and how often it makes mistakes. Finally, we examine the evaluation metrics to understand how effective our model is at detecting fraud. This helps us determine if the model is accurate enough to be useful in real-world scenarios. The fourth task objective is real-time fraud detection. In this, I had to explore the feasibility of implementing the model for real-time Fastag fraud detection. Real-time fraud detection is the process of identifying and preventing fraudulent activities as they occur in a timely manner. The goal is to detect fraud as quickly as possible to minimize financial losses and protect against security threats. The code for this is as follows. In real-time fraud detection, we import the necessary libraries, including pandas for data manipulation, random forest classifier, joblib for model serialization, and time for introducing delays. Then we proceed with the historical dataset, which is loaded from a CSV file containing transaction details such as timestamp, vehicle type, toll booth ID, and fraud indicator. This is basically the dataset that we processed before. We're in the feature extraction stage. features in the target variable were separated, and the features representing transaction attributes and the target variable indicating whether a transaction is fraudulent or not. The trained model is saved to a file for future use. The code then enters an infinite loop to simulate real-life data arrival where new data is continuously read from a CSV file containing new Fastag transactions. Predictions for fraud status are made using the trained model, and the results are printed. As you can see, I have run this code for a long time, and this loop was run for a lot of iterations. The loop pauses for 1 minute before repeating the process, mimicking the behavior of a real-time fraud detection system. I have tried to mimic a real-time fraud detection system, so this is the result for that. The fifth task objective is explanatory analysis. In this, I had to provide insights into the factors contributing to fraudulent transactions. Explanatory analysis involves exploring and understanding data to gain insights into patterns, relationships, and trends. Unlike predictive analysis, which focuses on making predictions or classifications, explanatory analysis aims to explain the underlying structure and characteristics of the data. The code for the same is as follows. In the explanatory analysis, we load the dataset and display the first few rows to get an initial understanding of the data structure. Summary statistics are calculated to provide insights into the distribution and range of numerical variables. The distribution of the target variable, that is the fraud indicator, is visualized using a count plot to understand the balance of fraudulent and non-fraudulent transactions. The relationship between transaction amount and fraud indicator is explored using a box plot to see if there are any significant differences in transaction amounts between fraudulent and non-fraudulent transactions. Finally, a correlation matrix heat map is generated to visualize the pairwise correlations between numeric values, which can help identify potential relationships or dependencies. And finally, I have included all the references that I have used for this project in this given slide. This brings me to the end of my presentation for the second project of my machine learning internship at Mentorness. This project gave me the opportunity to learn a lot of new topics, and I'm very grateful for that. With this, I would like to conclude my presentation. Thank you very much.